Hey guys, and welcome to 1.6. In 1.5, we talked about how to work with quadratics using computing square, factoring, quadratic equations, square root property, all that stuff to get to what are the values of x. And in 1.6, we're going to take that a little further and look at some different methods that will help you continue to factor or get things in factored form. So on number one, everything's already in factored form. So when it's already in factored form, you literally just take each factor so it equals 0 and find out what your x's are. So you got 5x squared equals 0, x minus 2 equals 0, x plus 2 equals 0, right? And then here, I'm going to get x equals positive 2, x equals negative 2. And then here, when I divide by 5, you get x squared equals 0. And then when you take square root of 0, you just get 0. So x equals 0. So x equals 0 and plus or minus 2. And because it's 2 and negative 2, you can write it plus or minus 2. That's just a shorthand way of writing it. And so there's that. Okay, on number 2, we want to get everything to the same side. Okay, so when you do that, I'm going to get 2x cubed minus x squared minus 2x plus 1 equals 0. Let me put the equals over here. I moved everything to the right. You just need to move it to one side, left or right. I usually try to keep my first term positive if I'm thinking about it. So now I have 4 terms. So I'm going to factor by grouping, which is a lesser known but still useful tool. So what I'm going to do here is I'm going to group the first 2 terms, group the second 2 terms, and then I'm going to take a GCF out of each one. So the first one has an x squared. So that's going to leave me with 2x minus 1. And then if I take out a negative 1, that leaves me with a positive 2x and a negative 1, which is what I wanted to show up to begin with. And so now you can see that each term has a 2x minus 1 in common. So I'm going to pull that out and pull the other things together. So I got 2x minus 1 times x squared minus 1. Now, if you know anything about factoring, you know there's some special cases. This would be one of them, where you have x squared minus 1. That's a difference of 2 squares. And so you're going to keep factoring until you can't factor any further. And so that's going to be x plus 1, x minus 1. Okay. And so again, all this is set equal to 0, and you're going to set each one of these equal to 0. And so 2x minus 1 equals 0, 2x equals 1, x equals 1 half. So x is going to be positive 1 half plus or minus 1. I say plus or minus 1 because it should be obvious to you that x plus 1, x minus 1, when you set each of those equal to 0 and solve, you're going to get x equals each of those. Okay. On number 3, I'm going to get everything to the same side. 6x to the fourth is the bigger power, so I'm going to move the 48x to it. So it's going to be 6x to the fourth minus 48x equals 0. Now, at this point, I'm going to take out a 6x, right? And that's going to leave me with x cubed minus 48 divided by 6 is 8. Okay, so again, this is one of your special cases. It's a sum. You can factor a sum or difference of 2 cubes, and 8 is a perfect cube. X cubed is a perfect cube. So this is going to turn into 6x. X minus 8. So you get your binomial. It's going to be a binomial and a trinomial. Your binomial is just the cube roots of both of your terms. So the cube root of x cubed is x. The cube root of 8 is 2. So there's that. And then you keep your original sign. Your trinomial is strictly built off of your binomial. You square your first term, you take your opposite sign, and then you multiply your 2 terms together. So 2 times x is 2x. And then you square your last term. And because you square your last term, it's always positive, and it's going to be 4 equals 0. Okay, now when you factor, you're going to get x equals 0 from the first term. You're going to get positive 2 from the second term. But when you factor the sum or difference of 2 cubes, that trinomial that shows up can only be factored with the quadratic formula. So let's do that over here to the side. That's going to be negative 2 plus or minus 2 squared minus 4, 1, 4, all over 2. Okay, so that's going to be negative 2 plus or minus 4, 16 over 2. It's going to be negative 12. All right, you can simplify radicals just like you can simplify anything else. And that's going to be negative 2 plus or minus 2i squared root of 3 over 2, which means this is going to be negative 1 plus or minus I squared root of 3. Now, I'd be happy to go through how I just did that in greater detail. Just reach out to me if you have questions about it. and I will, we can schedule a Zoom call or anything like that, and we can talk it out. But that would be my third term, or technically third and fourth term, because it's plus or minus right there. So these four. On number 4, this one's a little tricky. So let's check this out. I'm going to move the 8 to the other side. So it's going to be square root of x equals x plus, or excuse me, minus 6. Now, I would really like to get rid of that square root. So to undo a square root, you square it. Okay, and so that's going to be, I'm going to square both sides. Okay, and so that's going to give that, it's going to get rid of the square root on that side. And this is going to be x minus 6, x minus 6. I want to emphasize this, but I want to leave space too. X minus 6, x minus 6. Okay, so that's going to be x squared minus 12x minus plus 36. I'm going to get the x to the other side, so this is going to be 0 equals x squared minus 13x plus 36. And now I need to try to factor again, now that everything's on the same side. And it turns out that this will factor again. I'm just going to have to use different terms. Okay, so you got 9 and 4 are factors of 36. And because my signs are the same, I can use those. And so when I set both of these equal to x, or both of these equal 0, I get x equals 4 and 9. And here's the catch. Because I squared in the middle of this, I need to check my answers. So if I take 4 and plug it back in, you get the square root of 4 is 2, plus 8 is 10. And then 4 plus 2 is 6. That doesn't work. So 4 doesn't work. But if I plug in 9, the square root of 9 is 3, plus 8 is 11. And then 9 plus 2 is 11. So this checks. So 9 works. 4 doesn't. And it's all because I had to check it because I squared in the middle of the problem. So be mindful of that. It is tricky. The algebra gave me 2 answers, but only one of them worked. So be careful with that. Okay, now when it comes to 5, you're going to take out a GCF. So both terms have a 4 that I can take out. So I'm going to say 4. This is going to be x to 5/4 minus 11 equals 0. Now, it is perfectly legit and safe to go ahead and divide that 4 to the other side. And when you divide when 0 is on top of any fraction, the whole thing is 0. So essentially, I can drop this out and just work with the parentheses. And so now I'm going to add the 11 to the other side. And you multiply it. To get rid of a fraction, you multiply by its reciprocal. And the reciprocal of 5/4 is 4/5. So I'm going to take, like earlier, I squared to get rid of a square root. That's essentially what I'm doing here, but it's fractional exponent. And so when you raise the power to the power, you multiply it. So I'm going to raise this entire thing to the 4/5. 4/5. And what that's going to do is that's going to leave me with just x, and it's going to say 11 to the 4/5. And so that will be my answer. Number 6. Again, I want to get rid of that 2/3. So I need to multiply it by its reciprocal, and I do that by raising a power to the power. So that's going to be 3/2. 3/2. Okay, and so this is going to be x minus 5 just by itself. And then fractional exponents. This is part of one of your P videos. The denominator is the root. So I'm taking the square root of 9, and then I'm going to cube it. All right, the square root of 9 is 3, and then 3 cubed is 27. So there's that. And then I'm going to add 5 to both sides, and x is 32. Oh, I forgot. Because I took the square root, I have to consider plus and minus. So 5 plus 27 is 32, and then negative 5, or 5 minus 27 is negative 22. You got to watch out for the square roots. And this one wasn't quite as obvious because it was an exponent that you had to convert. So be careful. All right, number 7. On number 7, you want to get everything to the same side first. So let's get everything over here. And x fourth minus 58x squared plus 49 equals 0. Okay, now on number 7, we're going to use what they call u substitution. And that just means we're going to let u be x squared. And so if u is x squared, that means u squared is x to the 4th. And so this is going to be 9 u squared minus 58 u plus 49. And this just makes it easier to factor. And while I don't think on number 7 it's actually super useful, because you could factor it without doing the substitution, I think the u substitution would be more useful on number 8. But we'll get there in just a second. So when you have a number in front of x squared right here, you don't have, if it's not a positive one, then you can do what they call the AC method, which means I'm going to take the 9, throw it to the back, and multiply. So let's do that. So we'll take the 9, and take it to the back, and we'll multiply. Now, because we started the factoring off by multiplying, we're going to have to undo it later on. And so we'll get, but just know that we have to do that. So we have u squared, 958, u plus 39 times 9 is 441, equals 0. So now you need to figure out what your factors of 441 are. And that is going to be 1 and 441, obviously, 3 and 147, 7 and 63, 9 and 49, obviously, because it's what you multiply by, and then 21, 21. Okay, well, 9 and 49 is going to give you the 58 in the middle, right? So this is going to be vector u and u minus minus, right? They're minus minus because the second sign is positive, which means that the same sign, and they're both the same as the first sign. And so 9 and 49, right? And then this is where you have to remember that you factored or you multiplied at the beginning. So now you have to undo that. And how do you undo multiplication? You divide. So I'm going to divide by 9. And then I'm going to write this one more time. U1, U minus 29 over 9. There's nothing I can reduce here. And because I'm saying this equal to 0, I'm just going to leave it like it is. It's set each one equal to 0. So this is going to be U equals 1 and U equals 49 over 9. Now, this is what U equals, but our problem hasn't started with an X. So over here, if U is 1, that means 1 is X squared. And so what is X? It's plus or minus 1. Okay, if U is 49 over 9, that's X squared. That means X is going to be the square root of that. And when you square root a fraction, you square root the top and the bottom. So that's going to be plus or minus 7 over 3. So the square root of 49 is 7, square root of 9 is 3. And so there's that. And that would be your final answer. You start with X, you have to end with X. Okay, and so you did the U substitution to try to make it easier on yourself. You get it all the way down, you find out what U is, and you plug your factors, your solutions for U into your little substitution to get your values for X. So you started with X, you got to end with X. Okay, on 8, this is the one I said that it makes more sense to do it this way. And I want to let U be X plus 4. Okay, so that's going to be U squared plus 13U plus 42 equals 0. All right, let's factor that. Both sides are positive, so both of these sides are going to be positive. So it's the U plus and U plus. 6 and 7 is going to be 6 and 7 is 42 and adds to 13. Okay, so let's factor this. You said each one of these equals 0. We're going to get U equals -6 and -7. All right, so I need to plug those in. So it's going to be -6 equals X plus 4. So it's going to be -10. And you get -7, X plus 4. It's going to be -11. Okay. So there's one answer, there's two answers. Starting with number 9, we have absolute value. You treat absolute value like anything else. The only catch is, remember, the absolute value it can't be negative. And so if you plug a negative into it, the absolute value will take care of it and spit out a positive number. Until you get to the absolute value, you treat it like parentheses. So 5 goes into 25, so I can just go ahead and divide this out. And so that's going to be the absolute value of 2x minus 5 equals 5. And now here's what you have to do. You have 2x minus 5 equals 5, or 2x minus 5 equals -5. And that's simply because the inside can be either +5 or -5 and give you a +5 as your answer. So now I have to solve for both of these. This is going to be 2x equals 10, x equals 5. 2x equals, when you move that, it's going to be 0, so x equals 0. Okay, so x equals 0 and 5. That's all you do there. Right? Number 10, you have two absolute values, one on each side. Well, you do the same thing. You got 5x minus 5 equals 10x plus 4, or 5x minus 5 equals the negative of that. I don't know what that is, but we're going to find out. Right? So I'm going to move the 5x to the other side. So it's going to be -5 equals, that's going to be 5x plus 4. I'm going to move the 4 to the other side by subtraction. Let's see, that's going to be 5x equals -9. And so that's going to be x equals -9 over 5. Right? That's one answer. Okay. I need to clean this up before I do anything. So that's going to be -10x minus 4. Okay, now because the -10x, or because the 10x is negative, I'm just going to move it instead. Trying to keep my x is positive. It's just going to be 15x minus 5 equals Negative 4. Let's add the 5 to both sides. 15x equals positive 1. Divide, you get 1 over 15. There's your second answer. Okay. Last one, number 11. All right, so in a situation like this where they give you two equations, usually y equals something and y equals something else, you're trying to find out where the two meet. Okay, and so all you need to do, if they're both equal to y, set them equal to each other. So this is going to be absolute value of 6 minus 4x equals 14. And then this works exactly the same as 9 and 10. So 6 minus 4x equals positive 14, or 6 minus 4x equals negative 14. All right, so I'm going to move the 6. This is going to be negative 4x equals 8. X equals negative 2. I'm going to move the 6 here. It's going to be negative 4x equals negative 20. X equals positive 5. Positive 5. All right, so negative 2, positive 5, those are my answers. All right, guys. I hope you found that helpful. Hope you learned something. And if you have any questions, please reach out, and I'll see you in the next video.